Hello class, welcome to the next segment in Lab 3, and in this segment we're going to take a look at what's referred to as a loop, and specifically what we're going to focus on is the idea of a for loop, which a few other names for that is, or another name for that is something called fixed repetition, but you don't necessarily need to know all the terminology for all this stuff, you just need to know what it is and what it does. So the whole idea behind a loop is it's a way that you can get the computer to repeat some task or some set of tasks in a nice, compact, and efficient manner. So you might remember back to some grade school days where some teachers might give you the punishment of writing out some phrase 100 times, like "I will not chew gum in class," write that 100 times, and you had to write that out manually all at once. But you can actually get the computer to do all of that in a really nice compact way. In fact, we'll take a look at some examples of that as we go forward. But first things first, we want to focus on the actual setup of the for loop and how the computer is actually going to read this. So it's appropriately termed a for loop because it uses the word for. You'll notice that's highlighted in blue here. And then I have for something in range. And this is in fact treated like a variable. So in the previous segment, we introduced the idea of a variable which can hold on to some piece of information. So far, we've only looked at variables that can only hold on to numbers, single numerical values. Later on, we'll see some variations of that. But for now, just to keep things simple, this variable I right here is in fact going to hold on to just a single numerical value. So for I, and then we have in range. And then here, there's a few variations of the range function that you can work with. One of which is range with just a single number. Another one is range with two numbers, which is what we're looking at right now. And you can also have a range with three numbers, but we're only going to focus on range with two numbers because that's mostly what you'll need to be working with when you tackle the programming assignment. So range with two numbers, the first value or the first entry in the range function, that specifies the starting value for your looping variable, what's referred to as a looping variable, which is this I here. So the first time through the loop, when the loop first begins, our variable I here is going to assume a value of 1. And then as the loop progresses, the value of I will increase by 1. So when the first cycle through the loop, I will be 1. Then the next cycle through the loop, I will increase to 2, and then so on and so forth until we reach this upper bound, which is given by the second value in the range function. So the second value in the range function tells the loop when it should stop running. And in this case, here we're telling the loop, or we're telling the loop that we want the loop to stop running when our variable I, it reaches this value of 10. And at that point, the loop will terminate. So that's how the loop that's how the loop more or less works. And then also really important to note is this colon that appears at the very end here. And that is something that must be there. If you leave that colon out, then the program's just going to refuse to work at all. So just make sure you include that colon there. If you see an error message that looks like this, it means you forgot the colon. It was expecting a colon to be there and the colon was not found, so the computer threw a hissy fit and gave you that lovely error message. So now it works. And you'll notice what I got here when I ran this program. So here, this right here, you'll notice that this print statement is in fact indented, and that is not insignificant at all because whatever is indented, that's what's considered to be part of the loop. Whatever is indented is subject to be run every time the loop goes through a cycle. So anything that's indented below this for statement, that's going to run every time you go through the loop. So here this loop starts with the value, here the loop starts off with our variable I being 1, runs through the loop once, prints out what the value of I is. We get through the loop, we go to the next cycle, we get where I goes up to 2, we run through the loop again, printing out the value of I again, which is 2, and then we reach the end of the loop, so we go to the next cycle where I becomes 3, prints out the value of I, and then it just continues that process until we get to where I is equal to 10, where the loop discontinues. But I want you to pay very close attention to something in the console. You'll notice we have no 10 there. I is never 10. Or at least not in the loop, it's never 10. And this is something that's very important to keep in mind. This upper bound in the range function, that is not an inclusive bound. That means I is going to start at this value and then go up to, but not including the second value. So I is going to start at 1 and then go up to, but not including this value of 10 here. So up to, but not including 10 means the loop stops after I becomes 9. And you can see the last time through the loop, I is in fact equal to 9, or just simply one less than this number. And a little bit, something more that I should mention about the indentation here, you can put more than one statement inside of a for loop. In fact, you can put as many statements inside of a for loop as you want. So here I'll add another print statement. So here I'll do something like this. Now, the order here, the way that the computer is going to read this is when we go through the first cycle, it's going to run this print statement first. I must not chew gum in class. Then it's going to run this print statement after that. So here it's going to print I must not chew gum in class. Then it's going to print the value of I. Then we go to the next cycle. It's going to run this again, print I must not chew gum in class. Then it's going to print the value of I, which the second time through the loop we expect I to be 2. And then it's going to continue in that cycle again up until I becomes 9, and then after I is 9, we don't run the loop anymore. So you can see, even though we're running through the same statements over and over again, the order of those statements is important. What appears toward the top is going to run first, and what appears toward the bottom is going to be run towards the end. And a few other things, the way that you get this indentation is you just simply hit the tab key, and that creates the indentation for you. Now, there's a few things that we should note about the indentation itself. The indentation must be consistent. So if you try something like this where you have indentation this is actually 4 spaces here, and then you have an indentation that's 3 spaces, then you will probably get an error message that looks like this if you try to run this. Unindent does not match any outer indentation level, which is just a fancy way of saying that your indentation here is not consistent. Everything's got to be perfectly lined up. And if you put too many spaces in there, you'll get this error message instead where it says unexpected indent. So make sure that your indentation is consistent, and also make sure that you don't have any empty spaces, but make sure you don't have any empty spaces before any of your Python commands that are not part of a loop. Otherwise, you'll get the same error message, unexpected indent. That basically just means that you have a space in front of here which should not be here. So just make sure that you're only indenting statements that do in fact appear beneath a for loop or a similar command like an if statement or a function, which we won't cover if statement specifically in this workshop, but we will cover functions. So just something to keep in mind. Now I'm going to take this and change something real quick. So I kept the original indentation up here. I have for I in range 1, 10 colon. This statement's indented. However, this statement is not indented. What's on line 5? This print statement is not indented at all. So the way the computer is going to read this off, and remember, anything that's indented is going to be part of the for loop. That's going to be something that is subject to run every time the loop runs. But having this print statement that's unindented means this print statement on line 5 is not part of the loop. So that means that this statement is only going to run as often as it appears. And since it only appears once, this is only going to run once, whereas this print statement, because it's indented and also below this bit on line 2, since this is indented and below the bit on line 2, that is going to run every time the loop runs. So this will give us a result that looks like this. You can see we go through the entire loop, and then after the loop is done, only then do we go down to this print statement on line 5, and we'll only run that statement as often as it appears. So anything that's indented is subject to run every time the loop goes through a cycle, which in this case it goes through 9 cycles. And anything that's not indented, we only run that as often as it appears. It's just any other Python statement. There's nothing really that special about it. It just runs once. And there's really no limit to what the numbers that you can put inside the range here, as long as they're integers. So you can't put decimal place numbers with decimals in them. But if you want to, you could do something like this. So I mean, this will give you a lot of output in the console. Emphasis on a lot. I'm not going to scroll all the way up, but you can sort of get an idea of what running something 9,999 times actually looks like when you tell the computer to do that. It will do that without question if it's able to complete the task, but it may not be entirely useful to get all that information appearing in the console. But you can really put anything in here that you want. Just make sure that this number, well, just make sure that you have 2 numbers in here, and also just keep in mind that this is the starting value for your looping variable, and this is the ending value. And again, that's not an inclusive bound. It goes up to, but not including 10, as we can again demonstrate. You can see I stops at 9, and once I becomes 10, the loop does not continue. It just continues on, and there's nothing in this program that follows that. So here I'm using I. There's really nothing special about that. you can use anything as long as it's a valid variable name. So I could say for ASDF, as long as I'm consistent about that. So if ASDF is my looping variable, then instead of using lowercase I like I had in this print statement on line 4, just to remind you what that looked like. So now my looping variable is no longer I, which means I have to change this in order to keep the computer happy. But you can see this produces the exact same output. And if I want to do something really inefficient, but kind of silly, then I could also do something like this. For supercalifragilisticexpialidocious in range 1, 10, that is in fact a valid variable name, although a needlessly lengthy one. It still works all the same. So it doesn't really matter what you put here as long as it's a valid variable name, as long as you're consistent about it. So you can even use just a lowercase j. That will also give me the exact same result. So that's going to do it for loops. And in the next segment, we are going to discuss the idea of lists, which up until now we've been working with variables that only hold on to a single value. When we introduce the idea of lists, we will take a look at variables that can hold on to multiple values, and we'll take a look at how exactly that works in the next segment.